In addition to the U substitution that we talked about in 6.9, we will also have to potentially incorporate some pre-calc skills like division and completing the square. Okay, so we're just going to be doing some algebra stuff here that will add into what we know about integration. Okay, so when we have a rational function like these first couple, if I try and define this as like a u du substitution, I do have a quadratic in my numerator and a linear in the denominator. And if I try and say, okay, well, let's let the numerator be u and the denominator be du, the problem is I can't have 1 over du. So in other words, if I said u is x squared plus 3x minus 5, du would be 2x plus 3 dx. Even if that was a plus 3, I can't write this as the integral of u and then like half over du, but the dx is in the numerator. So anyway, either way, it doesn't work. Okay, it doesn't work. So instead, we are going to first divide. Okay, now because we're dividing by a linear, we can use synthetic division, but we're going to divide first, and then we are going to look at our remaining expressions to try and integrate those. Okay, so I'm just going to do the division off to the side here. And I will use long division. So 1, 3, negative 5. Okay, so 1 times 2, 3 plus 2 is 5, 5 times 2 is 10, and I have a remainder of 10. So this is equal to, haven't evaluated any calculus yet, I'm just doing algebra. So this is equal to x plus 5 plus, and then remember this is the remainder, so 5 over x minus 2. And all of that is still inside the integral. Let me make this a little bit bigger, okay? All of that is still inside the integral. Now I can do the integration for each of these pieces separately, okay? So that's going to be 1/2 x squared plus 5x plus, now I can treat this as a u substitution. This would be my u. My du would just be 1 dx, so I don't need to do any manipulating here. I have a coefficient of 5, so it's going to be 5. Now you can write this, separately if you want, but this is now 1 over u du, so 5 natural log of u, so natural log of x minus 2 plus c. And again, if you want to write that separately and like write out the u substitution, totally fine. Okay. All right, and there's my antiderivative function. Okay. So let's do another one. Again, I could try and set my numerator equal to u and then see if, because my denominator would be a quadratic and a constant term. The problem is it's not going to match what I have down here, and it can't du can't have part in the denominator. And I have a higher degree in my numerator, so I know that I can divide. Okay, I'm going to use long division here because I'm dividing by x squared plus 4. But once again, I'll kind of do that off to the side. So we have 3x cubed. Don't forget to leave space for your x squared term, plus 2x plus 5. And we're dividing by x squared plus 0x plus 4. Okay, x squared goes into this. Let's see, 3x times. So normally I would stack that on top of there, but I'm going to put it right here. So 3x, so 3x cubed plus 0x squared plus 12x. And then we are subtracting. So we get, so that's 0, 2x minus 12x is negative 10x. Bring down the 5. Okay, 5 comes down. And then how many times does that go into there? It doesn't, so this is my remainder. It's plus negative 10x plus 5 over x squared plus 4. Okay, be careful with that negative. You can't make this a negative or else it would apply to both. I could make it a negative here and make this a positive 10x, but then this would be a minus 5. That's fine. Just be careful with negatives. Okay, so what does this equal? This is equal to the integral of 3x. Okay, that part's going to be easy. And then plus negative 10x plus 5 over x squared plus 4 dx. Okay. The 3x part, easy to integrate there. The negative 10x plus 5 over x squared plus 4 is a little bit trickier here, okay? As it is, if I try and make this like 1 over u du, my u would be x squared plus 4. My du would be 2x dx. I have an extra constant, and the coefficient can be manipulated, but I wouldn't be able to get rid of that plus 5. Okay, so I could also think, well, maybe this is a tangent inverse problem, but the problem with tangent inverse is that I have an extra variable of x in my numerator as well. So instead, I'm actually going to split this into 2 different fractions. Okay, so coming over here, this is equal to, and I'm going to integrate that first part. So that's 3/2 x squared. Okay, or you could do it later, doesn't matter. And then I'm going to write this as, nope, I'm going to write it as minus 10 just to factor that out, times the integral of x over x squared plus 4 dx, and then plus 5 times the integral of 1 over x squared plus 4 dx. Okay, so now I do have a u substitution. How do I get rid of this? I have a u of x squared plus 4, so my du would be 2x dx. So I'm going to multiply by 2 here, divide by 2 there. And then over here, this is tangent inverse of x, where a is equal to 2. Okay, so all of this becomes 3/2 x squared minus, okay, so this is 1 over u du when I do that substitution. So I have 5 natural log of u, x squared plus 4, and then plus 5, and actually it's going to be 5 times, since a is 2, I need a 1 over a in front of that. So 5/2 tangent inverse of x over 2, and then plus c. So that is my final answer for that one. Okay, and I did kind of skip the steps where I write out like the u substitution. If you would like to see those, let me know, but we could also go back and look at 6.9 to kind of see how that part is done. The process with this one is similar to the previous ones. I'm not going to work this one out, but it will be, the full solution will be on the completed notes, so you can check it there. All right, and then I'm going to stop this video and then finish the rest of it with completing the square in the next video.